Um, Good morning, folks. Thank you for attending this meeting. The topic of today's discussion is issue 6647, Bridge, MLflow, and Kubeflow. I'm Jagain Sundar from InfinStore, and I have my colleague Raj here. My other colleague Jitendra will join us at 8:30, that's about 30 minutes from now, to do the live demo. He has to drop off his children at school and be back. So Bridge, MLflow, and Kubeflow. Our goal in this proposal is pretty simple, actually. It is to enable users to use best-of-breed tools for AI and ML work. It comes with the understanding that there is no one single winning platform so far as AI tools are concerned. Over the last few years, many successful tools, open source and not open source, have emerged, and people have, users have grown attached to specific things for specific purposes. It's a multi-tool, multi-cloud, multi-hardware universe, and I think it's very useful to have the ability to choose best-of-breed tools. It's a humble goal, but it comes with many thorny issues. Let me start with what types of MLflow. I'm going to focus on MLflow a little bit because I think as participants in the Kubeflow community, perhaps many of you don't have an understanding of how MLflow itself has evolved in different directions and has taken on some attributes that are making it successful for specific problems in this space. What types of MLflow? The first one I'm listing here is hosted services such as Database MLflow, Azure ML version of MLflow, and our own InfinStore MLflow. Second, of course, is Kubernetes hosted MLflow, which is basically a version of open source MLflow, perhaps with some authentication built by means of Helm charts or other means. User management is still a question. I don't fully understand whether these mechanisms have user management built in or not. Open source MLflow does not include any authentication or authorization. We've also heard of enterprises that have taken open source MLflow with their own custom authentication software and have rolled it out enterprise-wide. We would like to support those as well. We believe that it is within the realm of possibility, and it would be foolish of us to ignore those environments out there. So what does it mean when I say service hosted version of MLflow? Exactly what are the benefits? What do you get over and above that which is included in open source MLflow? The examples here are Databricks, Azure ML, and InfinStore MLflow. The first thing that comes to mind, and the reason why many of our customers switch our product, is authentication using the corporate directory. This is built into these services, and it's an essential aspect of how customers use the software. Authorization turns out to be a pretty big deal as well. I'll go into a little bit more detail there. And finally, data management. The reason for why data management is an aspect of this will become clear as this presentation goes forward. Authorization in MLflow, particularly the service versions, is built around experiments and models. You can specify that certain users and groups have certain roles, reader, editor, manager, for whole experiment or models and all the versions of the models. There are many regulatory reasons why this is an essential aspect of both experiment and model management: HIPAA, GDPR, CCPA. One might think that the raw data is where authorization is established, but it's very easy to write Python code where you just take the raw data and write out the raw data in some easy manner. At that point, you are violating CCPA or GDPR because the second stage of processing essentially has access to data that should be protected. So that's a long-winded way of saying you need to be able to authorize experiments and models in a enterprise setting or a regulatory concern setting. Second reason why people want authorization is intellectual property protection. There are companies out there, financial services, healthcare, biotech, that are spending millions of dollars building these models. And if somebody walks away with a model, that could be pretty destructive. In order to protect themselves from issues like that, you do need to you do need the ability to uh, protect intellectual property. It is always necessary to integrate with corporate directory and user group information, and very undesirable or not even a workable situation to have a separate set of users or a separate user database with group database and associated authorization. It simply doesn't work in a corporate setting. So data management, this was the third aspect, and this is a subtle thing that turns out to be a real problem in an enterprise rollout. Open source MLflow does not include the ability to manage credentials for the artifact directory. For the moment, let's assume that things are ending up in a S3 bucket or in some S3 compatible storage. What MLflow does is it basically calls Boto3, the Python client for Python client for S3, and farms out credential management to that piece of software. So if you're running it from your laptop or your desktop, you need a home directory /.aws/credentials with the AWS secret access key and access key ID if you want to access that artifact bucket. Even though the user is calling a Python log artifact call in the MLflow library, it is actually ending up in a AWS credential authentication system. And what is worse is if you have extraordinary circumstances, or if you're running this in a AWS environment, you can set it up so that the credentials are available in that particular environment. Otherwise, it's a laptop, it could be a desktop, it could be a container in a Kubernetes cluster, which is doing some work. All of those particular entities where that log artifact call is being called need access to that credential. As you can imagine, and this is a completely different set of credentials, right? It's not your Active Directory credentials, it's not your OAuth token, it's a completely different thing. And handling that, managing that, providing read or write access is all a whole new problem domain that MLflow open source dragged into the system. So it's really not a workable situation. We, and for example, Databricks have encapsulated all of that and offer a system where the credentials management is handled by the library. Now, I will mention this. All of the software that we wrote for handling that is part of the open source concurrent project. So the concurrent project brings in the capability to manage credentials for data that is going to be used in the compute. And that's why that's one reason why the data management is so critical and such a intertwined part of the compute management system. Finally, MLflow services such as Databricks and ours enable data versioning by different mechanisms. The underlying file systems have snapshot capabilities. Sometimes there are things like Delta Lake, which Databricks builds, and InfinSnap, which we build, which enable data versioning. That part of it is basically depending on the lower layer of software offer, but the API needs to be able to take care of that and report that. Okay, let's talk about challenges with MLflow integration. This is where I think we will need to focus on just from how do we bring MLflow in as a first-class experiment management and model management system into Kubeflow. Authentication and single sign-on are a pretty big pain in the backside as best as I can see, both because MLflow doesn't include authentication by itself. I'll go into some more details on what is common out there. Artifact management, as I mentioned, artifact management and credentials for artifact management is a pretty thorny problem. User interface integration. This is important. If the user interface is clunky and you don't have smooth ways to go back and forth, it turns out into a problem. Later in this presentation, Jitendra will, oh boy, later in this presentation, Jitendra will demonstrate how we do this whole action of going back and forth between runs, recorded, and our concurrent interface. And I think that's essential for usability of the system. So let's talk about authentication and single sign-on for a little bit. As I mentioned, open source MLflow does not include authentication, but hosted services do include authentication. Databricks and Azure ML use an environment variable called MLflow tracking token that needs to be set and available in all the places where the compute is happening. Otherwise, you can't access the MLflow service. We go one step further, and in addition to the environment variable, we have a token file with a refresh token. So if you have a long running activity such as training that takes 10 hours, and if your token expires, we have the ability to refresh the token. That will be available as part of it's included in the concurrent source code base. So it will be a natural part of the whole system. Artifact management, I mentioned this earlier and talked about how it is a big problem to handle S3 credentials along the way, and that MLflow does not really deal with the problem of artifact authentication. And we need to include that if we do anything with compute. It's just an essential part of the system. User interface integration, going back and forth from Kubeflow UI to MLflow UI is critical. You will see in the demo later today that we have integrated ourselves as a tab in the MLflow interface, and we can go back and forth between the experiment tab and the concurrent tab, because the concurrent itself runs the DAG as one parent run in MLflow, with every node in every instance of every node in the DAG becoming a child node. And you can go back and forth. You can click on it, look at it in the experiment view, or you can look at it in the concurrent view, which will show you the hierarchy of how things got started and are running. That's essential. You need to be able to integrate MLflow user interface into Kubeflow and be able to go back and forth, and that makes for so much better user experience. Now, let's talk a little bit in detail about concurrent. That is the topic of this presentation. All the time that I've spent so far is to highlight that open source MLflow is limited in its functionality, and the problem space actually expands beyond open source MLflow, because most commercial enterprises are using service-based MLflow. And also, I mean, the thing that I didn't call out, which I should have actually called out, is having a service MLflow makes for sharing models and experiments very easy. If you do not have a ability to authenticate and authorize users, and sharing models is tricky. It becomes really hard to do. That is an important aspect of this. All the things that I've talked about MLflow will be demonstrated by Jitendra later. I saw him just join the meeting, so he will do that. So what is concurrent? It is a Kubeflow component, we hope, that enables users to run complex DAGs of AI computation in Kubernetes while using MLflow for experiment tracking, artifact management, and model management. Now, it's designed for complex pre-processing of AI data and for micro-batch inference. It uses a lot of constructs that are very familiar to people handling unstructured data. I still think that if you have structured data, for example, things that fit in a row and table form, and you want to do some processing on it, concurrent is perhaps not the best tool for you. I think your options for that sort of a problem are Snowflake or Databricks or the Spark operator in Kubernetes, which I believe Kubeflow manages or is very easy to use from Kubeflow. This is not trying to solve that problem. This is for solving problems where unstructured data is in use. You've got images from CT scan machines, you've got Twitter tweets and other language articles picked up from the web, and you're doing NLP on those. You've got videos from highway traffic monitoring systems, and you've got network packet captures from honeypots located all around the world. These are not things that work well in a structured environment, and that is what this system is designed for. What is it not good for? It's not suitable or not really designed with the notion of real-time inference. Starting a fleet of inference instances and putting a load balancer in front, that's not a problem that we solve well or we tried to solve. It's not really suitable for distributed training. Tools built into TensorFlow and PyTorch are much better options for that particular use case. So let's take a look at the architecture. I will, start with this disclaimer. This is the architecture that we have today, and we expect to need to do some work to make it acceptable to the Kubeflow community. And I'll start off with the biggest controversial item right up front. Our control plane lives in the cloud. Today, it is built as serverless functions, Lambdas, AWS Lambdas to be specific. And the persistent information is stored in DynamoDB. And we use certain constructs in DynamoDB for locking and coordination and so on. We expect to build, as part of this project, we expect to build a version of the control plane that lives completely within a Kubernetes environment in order to make it acceptable to Kubeflow. We've known this all the while, and that's fine. That's part of that's one of the big ticket items. User interface integration being the second big ticket items. And we do have resources for both of these, and we're happy to contribute this code as part of this project involvement. The second major thing I want to point out here is that from the get-go, we have believed in multi-Kubernetes, multi-region architecture, because the customers we spoke with came up with problems such as, I don't have the latest version of NVIDIA GPU in the region where I'm doing my work now. I need you to do this in US East 1, where the latest NVIDIA GPUs are available. Or specific architectures of compute are not available here. I want to run it in a different place for that. Parts of the DAG may need to run in a different region in a different Kubernetes cluster. The second thing that we have found, and this is more to do with the nature of this work and why it's different. Jitendra and myself, we come from the Hadoop background. Jitendra knows a great deal about this, but one of the things that we've observed there is that if you ingest, like, say, 10 terabytes of data and use some SQL engine like Hive or Databricks, Snowflake, or something to run queries on it, you're probably going to read through the 10 terabytes and skim through it pretty fast and produce some results. You're not really going to be crunching on that data for a long time. Contrast that with AI use cases where you may copy out 10 or 20 gigabytes of data, but the compute on that may take hours and hours. So what this means is that the cost of copying data out of a particular region, moving it to a different region, actually becomes a small fraction of the overall cost to the customer. So it is beneficial to be able to move data between regions, between clusters, and have processing done in an optimal fashion. Given that consideration, we decided that the control plane necessarily has to live outside of the Kubernetes that's running. It can live in a Kubernetes, but basically we treat Kubernetes and expect that as a source of compute resources for us. And that design center led to a lot of interesting use cases for customers. So one of the basic assumptions we made is that we will use MLflow wherever it is strong. And MLflow has strong acceptance in the community for experiment tracking, model management, and integrated data management. There's just absolute love for the product there. People have built these auto logging facilities into the ML tracking libraries, so you don't need to deal with any of that. And one of the advantages of having that is if a particular library is maintaining the auto logging capability within that library, then it becomes their responsibility and it becomes MLflow's responsibility to make sure that it works together well. End users are less affected by problems where a new version of MLflow broke their existing system's logging. It just works. And that is a huge problem. I mean, if you think about it, Python with this, huge list of libraries, if a new update of MLflow suddenly broke all of your users' Jupyter Lab notebooks or their runs, it's very frustrating. That is a single great reason why using MLflow for experiment tracking makes absolute sense. Model management, again, we think that MLflow is the most sophisticated model management system out there. There may be others who have questions about that, but we found the features in MLflow to be pretty sophisticated. Finally, I talked at great length about data management, and that is, in fact, a really good feature to have integrated into the system. So experiment tracking, I talked about auto logging, why that is very popular in most ML libraries. Comparison across runs, this is a very useful feature. I think TensorBoard is actually more advanced than MLflow in this particular aspect, but MLflow has improvements in the pipeline that will make comparison across runs even better. And it's a very useful feature. As I said, it's very popular among users. Model management with this notion of staging, production, archive, and moving between these different stages, and having authorization for moving between these stages, which Databricks does, is pretty useful. It helps turn this into a more formal, structured environment which enterprises are moving into. Authorization for access to models, again, it's an intellectual property question. There may be certain groups who are authorized to access the models in read mode, other groups that are allowed to modify it. By that, I mean publish a new version of the model, put it into staging or production or archive. Such fine-grained control is an essential aspect of model management. Lineage of model, you can go back, look at older versions and see where the run came from. And if you have data versioning enabled, you can look at everything from code to data to the actual production of that model. So again, I'm talking at great length about data management. Concurrent is great at pre-processing of data. So we spent a great deal of time talking about partitioning of data and parallelization of the pre-processing. What do I mean by partitioning, right? Let me give you two examples to highlight that. Let's say you have CT scan images coming from CT scan machines in several centers, and each of those is organized by directory. Each patient scans come in a directory full of DICOM images. You want to partition this data by directory because you don't want to take a single patient's CT scan images and send that to 3 different instances of a node. They all need to be processed by the same node. So this would be a directory by directory partitioning system, which is built into our platform. Let's say that you are looking at news articles. They're all getting dumped into a particular prefix in an S3 bucket. That is the case where there's no relationship between 2 different objects, and you want those partitioned object by object or file by file. Again, this is another built-in operator in our system. Finally, we have custom operators. And here's a great example of that. Let's say you have honeypots sitting out in the world looking at people trying to attack your SSH ports. You use a piece of software that, this is an example that we're putting out there, by the way, that has the notion of events, connection, disconnected, that sort of thing. Each one of these connections has a session ID, and the system writes out events as objects to the S3 bucket, but you want all of the objects written for a particular session to be processed by the same particular instance of that node. What you do is you build a custom Lambda, which is basically a Python Lambda, a single line Python Lambda that takes all of the session objects and sends it to the same partition. This is what I mean by partitioning of data for parallelization. There is no talk about parallelization without partitioning properly and sending the correct data to the correct instance so that you can do the pre-processing accurately. We spend a great deal of time on this. This is something that I would like to talk about in the context of KFP, because we want to figure out how we can work with KFP. Perhaps, I'll put some proposals out at the end of the day, at the end of this talk, and we can go over that. So access to data, particularly in a different Kubernetes cluster, it could be in a different region, is critical. So there are 2 things that are problematic here. One is authentication. How do you get the credentials to access the data? Second is AI and ML has often read the same data over and over again. You want to make sure that they are cached in the right side of the WAN link so that you don't copy them over the WAN more than once ever. I think that needs to be an essential part of the system, and we have thought about it in concurrent. We expect to do that as part of the core feature set. Simply stated, concurrent really needs to manage the data, otherwise nothing works. It just becomes a toy piece of software. You can write hello world and you can have it parallelized and printed out hello world 100 times, but essentially we need to manage the data, otherwise the software doesn't really work well. Concurrent is multi-Kubernetes, potentially multi-region. Again, I spoke to this at great length. We want to be able to run a single DAG across multiple Kubernetes clusters, even distributed across the WAN. So I understand, I mean, this was an item that came up in the issue 6647 discussion. My understanding is that KFP uses Argo workflows. And right now, Argo is limited to a single Kubernetes cluster, but the ability to talk to multiple Kubernetes clusters is being proposed. And I think it's almost there. That's a welcome addition, but still, I think what we aspire to is bigger than that. We want to be a control plane that can control multiple Kubernetes across multiple regions. And we want to build that control plane with the proper consensus algorithm and the proper techniques in the system, first class. We don't want to depend on some underlying layer to do that, because sometimes these things don't work right if you don't design it as a core design principle. So this is one of our design centers. We want multi-Kubernetes, multi-region. We can have a discussion about this, and I'm happy to participate in that. Now, parallelization, partitioning data, compute in parallel. I talked at great length about predefined partitions for objects, directories, custom partitioning, and right now parallelization is pre-configured. So you design a node. When you design the DAG, you create a node using an ML project, or shortly we'll have KFP component compatibility as well. You can pick a KFP component and say, this is the node. I want 4 instances of this node in cluster XYZ namespace ABC. We can do that, and that will be part of the DAG. In the future, that is in the near future, we want to auto configure it. You specify that this is what I want, and here's the parallelization function. We can look at it and say, okay, this one requires 2 gigs of memory and 1 GPU. I've got 3 nodes that I can do that. I'll parallelize by 3. That sort of intelligence will start coming into concurrent. As I mentioned, parallelization and partitioning the data to parallelize well is a core design center for us. We have pre-built support for popular Kubernetes. This is another thing we passionately believe in. Since our control plane lives outside of Kubernetes, we want the ability to enter the Kubernetes and submit a pod. And so we do things like we have support for EKS and GKE today. So for EKS, what you do is you bring your AWS role and external ID, and we will use that to take on, assume that role, and we'll submit the job to the Kubernetes cluster or clusters and get the work done. We do not expect to be running inside the Kubernetes cluster and have external software or configuration to take care of permissions for us. This makes for a much better user experience, because we can now say the administrator can specify a Kubernetes cluster for everyone by default. Each user can come in and say, I want to add a Kubernetes cluster. Here's my AWS role. Here's my external ID, or here's my Google GKE service role, and put that in there. And then he or she can use that as part of the DAG definition. There's no assumption that the software runs inside the Kubernetes cluster. So authenticating through and updating authorization form tasks is important, and it's a big part of the software. We've written software to do that. So we support multiple namespaces out of the box. Docker operations. This is another sticky point, right? Our target end user is actually data scientists and MLOps staff who are using various tools could be Jupyter Lab notebook, could be whatever, but they're not necessarily familiar with Docker, managing container images and things like that. So what we say is, give us the Docker file and we will create the container. We will store it in a registry. We will update it if you update your Docker file. We'll cache it and we'll make sure that that container is available to that container image is available to whatever Kubernetes you're using for this particular purpose. We want to be responsible for that because we think it's a big stumbling block in making people use a Kubernetes-based system for compute. I mean, Conda used to work really well for Jupyter Lab and other things, but licensing limitations are making that problematic both for MLflow and other users outside. So you see a move towards Docker file and Docker environment, which we love, by the way. We've had Docker files that have been functional for years for us now without problem. Conda never does that. Conda craps out after a few months. It just becomes unusable at that point. But anyway, the point I'm trying to make with this is we take over the responsibility of managing the Docker images, and you just provide us with a Docker file for each node that's for each ML project. So I'll put this thing out there. This may work, may not work. I don't know enough about the KFP system to make this claim. But one way we could integrate is, just like Tecton, make concurrent an engine for KFP. We'll take the KFP DSL. We may need to extend the KFP DSL in some ways, but most of the work will be done in our engine. I don't know if this will even work. Much more work needs to be done before we can make this claim. Today, we have started a project to take KFP components and use them as the code for a node in the DAG. That we expect to be relatively straightforward, and hopefully we can get that done in a matter of weeks. But this one is a bigger project. We need to understand the KFP DSL, find out where and how we need to integrate with. But this is something that I'm going to throw out there. At this point, I'll hand over the, we have 22 minutes, so I'll hand over to Jitendra. Hey, Jitendra, I am going to hand.
Hi, everyone. Okay, let me share. Oh, again, the sharing is disabled for participants.
Okay. Advanced sharing options, all participants. Okay, try it now.
Yes.
Perfect.
Perfect. Okay. Okay, can you see my screen?
Yeah, you can.
All right. So so this is our concurrent freely hosted service in which MLflow UI and concurrent are integrated together. And MLflow is InfinStore's free service. So I will also demonstrate some of the features that InfinStore has added on top of open source MLflow. So as the first part of the demo, I'll show the an overview of MLflow, some of the features that MLflow offers. And in the later part, I'll show a concurrent execution. How we can build a concurrent and run it. So let's go. So this is the unauthenticated system. So we have a user account. I mean, the documentation talks about how to get signed up to this service. And so you will get a username and password, and once you log in, so this is the standard MLflow UI. We have experiments, models, and the concurrent tab also shows up there in this integration. So on the experiment side, essentially you can define experiments and track the execution of each and every execution. So to define an experiment, all you need to give is an experiment name, and it will use a default artifact location, which is a bucket in S3. But you can choose your own location as well, and there are documentation to do that as well. So once this is created, using MLflow APIs, you can when you run an experiment, it will show up here as the and all the details of the run will be are captured over here. So let's look at one particular run here, and here you see that all the parameters of the run are recorded, and all the metrics associated with the run are available. You can click on the graph, get the graph of a metric and see how it's behaving in runtime at runtime. You can add a tag for the run, because I mean, over the period of time, you have hundreds of runs. So to search for a particular run or to look it up, and so these tags are very useful. And if your run generates a model, then this all the model data available can be logged into MLflow, and all the model data information like its dependencies, the environment, and the actual serialized model, which is a pickle file in this case, and all the dependencies are recorded, and the actual execution logs are recorded, because and all the project files like your code or the Docker file that was used to do the execution is also recorded. So this is very useful feature because now you have the whole history of the run is available here, and which is used for debugging. And this permissions is an addition that InfinStore has added. So
Databricks also has permissions in their system.
Yeah, Databricks also has. I mean, so open source stock MLflow does not have it, but we have added these things. So you can add permission for a user. We define editor, manager, and reader roles, or you can add permissions for a group, and the system will honor that. This is important for when multiple data scientists are working together, when multiple groups are working together. So, so once we have a model, we can actually register that model into the MLflow's registry, which is also integrated here. So you can, so every time you create a new model, you can add it as a version of an existing model, or you can give it a new name altogether. So like in this case, okay, let's give it a new name, and it's an elastic net model from sklearn. So we registered a version here for that. So let's go back and give another version. So now this was another run, and for that we give it a new version. So for this particular model that we have stored here, there are two versions available, and so I already have 3 models there. And so another facility that it provides is you can manage the life cycle of the model. So you can designate a model for production run or staging run, or older models can be archived away. And again, model versions can be tagged, and you have the complete history. Like you click on this run ID and you go back to the run which actually created this model. So you can go back and see that what really happened when this model was executed, what was the data, and all the details of the run. Permissions, just as for experiments, the model permissions are also available. So the same user group level permissions with the role editor, reader, or manager role. So like we can add these permissions here. So one more thing, like if you look at all the details of the runs, you can search based on some of these parameters and matrix. Like if you want the model with least amount of error, the run which had least error, you can search for it, or search on various parameters or tags. So basically accessing your executions, their history is really simplified. Another thing that people use it for is to log the artifacts. Like if you have a multi-stage execution pipeline and you produce some intermediate data, so that can also be logged in as an MLflow artifact. and which will be available for future references for reusing that data or for any debugging purpose. So and actually there is a visualization tool also available for certain kind of data. You can actually see it in line right on the UI. So this is was a like a brief overview of what MLflow can do. Let's now switch gears and go to concurrent, like what concurrent does for and how it interacts with MLflow. Because so in concurrent, I mean, in this demo, I'm using the term parallel because that's what initially what we have changed it to concurrent. So you basically create a concurrent and you design a DAG. And when you design a DAG, you basically give a node name and you specify where that node needs to be executed. So the location right now, like we support GKE and EKS, but we are working on adding other Kubernetes distributions as well. You can pick the resources and specify the parallelization, like how many parallel containers you want to run. You provide the location of your ML project, which is a Git path, and then similarly we add another node, and in the end we will connect these nodes together to make the full graph. So like first node was in GKE and second node in EKS. So multi Kubernetes is something that we support out of the box. And when we connect this together, we have to specify a few things. We give it a name and we use a partitioner. An idea of partitioning is that how this node will get partitioned into multiple containers. So we define an input. This is the S3 bucket, the path in the bucket. And so among the partitioners, we have some built-in partitioners like directory and all, but there is a custom partitioner where you can specify a Lambda function. Use that for partitioning your data. So similarly for the second one consumes the output of the first one, but it also needs a model for classification. So we specify that as well. The second one does not need a partition, so we leave it as it is. And we save this design. So once this DAG is saved, we can just execute it at runtime. Also, you can override some of the parameters, but let's just run it as it is. And then it launches in the backend, configures Kubernetes. So we can see that the first node got split into 2 containers. So essentially, this is where the parallelization kicks in. And now they are scheduled to run in 2 different containers in the GKE cluster that we had configured for the first node. And in MLflow, we can see that there is a parent run and 2 child run created out there. So this works in tandem with MLflow. And for the data flow also, we used MLflow because all the data that first node will generate will be an artifact recorded in MLflow. So it helps in debugging or reusing intermediate outputs. Then Kubeflow interface is also can be used to monitor the progress, but all these logs are recorded in as MLflow artifacts as well. So if you're not familiar with Kubeflow, just from the MLflow and concurrent UI, you can get your work done. So this is where we will just wait for the execution to complete. We can see that, so we go to the parent run, and this graph is actually shown in the MLflow UI of the parent run. So, okay, so the first stage is complete. And the second stage is also split 3 ways because the parallelization specified for this stage was 3. So we have 3 containers there running. And the data from the first output gets partitioned appropriately to go to those 3 nodes. Now we switch the context to an EKS cluster and look at the pods over there. And in here we see that there is a bootstrap container running, and then there are task runs which are under execution. So this should also complete in. Okay, so now 33% is done. Okay, all of it is done. So we can go back and see that, okay, now MLflow UI also reports that the experiment run is complete. And as I showed in MLflow UI that now you can go back and look at the output or the models or anything that is generated in MLflow. So yeah, that concludes the demo.
Thank you for that, Jitendra. Let's open it up for questions. I think it ran a little bit longer, but any questions?
Hello, this is James Liu. Thank you so much for the presentation. I do have a question because you mentioned the proposal is to add some changes for integration with concurrent in the KFP DSL. Like, why do you choose this approach, or have you considered other approaches?
So it is just a proposal. We are, exploring ways of integrating with Kubeflow. And I will freely admit I'm not an expert in Kubeflow. So if you have other ways that you think might be better for integrating, yeah, we're open to suggestions. It's just one that I thought might be possible. Feasibility is there in addition to actual desire to do it.
I see.
Sorry, go ahead.
Another question I have is that is concurrent enterprise solution for MLflow, or is it also offering as part of the open source MLflow?
So there is no enterprise concurrent. It's 100% open source in our GitHub tree. You can go take a look at it now. Everything that Jitendra demonstrated came from our open source tree. We are developing on that tree. So when we contribute code to Kubeflow, it'll be 100% open source. There will be no component that's an enterprise version or anything like that. From our perspective, we think that there are some complicated integration issues, like the user interface integration is going to be complicated. There are a few other things. I'm not sure what. So we don't have an enterprise version. This is, we sell an enterprise MLflow service, but we don't intend to turn concurrent into an enterprise software. From our perspective, it's just it's a really interesting way to bring together two open source communities. And so we are in communication with Matej and Matej Zaharia, the inventor of MLflow from Databricks. And if we need anything done on the MLflow side, we're happy to work on that also. That's part of this thing. But we believe that both communities will benefit from this integration. We're part of the MLflow ecosystem, and we benefit from any benefit to the MLflow ecosystem. So that's.
So one more thing, like, so in the demo I showed along with an InfinStores MLflow deployment, but a concurrent works with other distributions of MLflow also, because we use only standard MLflow APIs. So it works with the open source or Databricks and yeah.
Oh, thank you. May I ask the question about the relationship about the concurrent and MLflow? Like, is concurrent part of the repository in the MLflow?
No, it is
GitHub
not.
organization. And
no,
why is that?
So we are working with Databricks' developer relations folks, and we want to make sure the two work together, but it is concurrent for MLflow. And it's something that we believe is a good bridge between Kubeflow and MLflow. But one of the, so here's the thing, right? Databricks believes that they have the compute problem solved because their data warehouse does a really good job of computation on structured data. I'm not convinced that they are focused on unstructured data like we are. And I will be the first one to admit, if you're trying to do structured data in concurrent, it's really not the right tool for that. Databricks or Snowflake or the Spark operator in Kubernetes are better options for that. So given that that's not MLflow's focus, is this really part of MLflow, or is it a great bridge between MLflow and Kubeflow? That's the question we have to ask ourselves.
I see. Yeah. Thank you. Thank you for the answer. I will give the room to other questions.
Thank you.
Yeah, I think I need an architecture diagram of what you're going to do and how integration is going to look like. Which components explicitly do you want to add to Kubeflow, which ports, which services, and which namespaces, all the details of your of the proposal.
Right. So we don't have a clear answer to that. More work needs to be done before we can give a crisp answer to that. The one proposal that I put out there is maybe we could be an engine for KFP like Tecton. But that may not be a simple answer. That may not be feasible in some ways. That may not be a simple answer because we do a great deal of work with data management also. And it's not clear to me that that's feasible. So the short answer to your question is we don't know. We're looking for input, and we will investigate more and work with anybody who's interested. But without data management, without the MLflow, we have dependencies on MLflow for a lot of things. Without those things, it makes it less possible to integrate. So that's the thing you have to remember.
So are you actually willing to integrate MLflow and Kubeflow into Kubeflow and not the other way around? So really just one Kubernetes cluster, Kubeflow and MLflow inside this cluster only, no external stuff? Or what is the long-term plan? Because from the presentation I get that it's more about using MLflow to run tasks on different Kubeflow instances, but this is would not be integrating MLflow into Kubeflow. It would be the other way around.
So, I think it is useful to have the ability to talk to any MLflow, be it one built into Kubeflow, into Kubernetes, or one that is outside. And the reason is because as I pointed out in the first half of my presentation, the service versions of MLflow are much more capable and much more acceptable to enterprise customers than open source MLflow. So with a little bit of extra effort, we can make sure that any component we put into Kubeflow will work with both internal built-in MLflows and external service MLflows, and that will help enhance Kubeflow. I think it's beneficial to Kubeflow.
Okay, so do you intend to replace Google's ML metadata that is currently used and it has, of course, several shortcomings inside Kubeflow? Do you want to replace it in the long term with artifact lineage tracking and so on in MLflow?
So that's a very strong statement. I think that users will decide what they want, and many of them have, chosen MLflow. Others have chosen Kubeflow, parts of Kubeflow. But I think the only thing we are saying is that if there's a customer who's got MLflow running, whether it is internal or whether their data scientists are just using local versions of MLflow, the components that we put in will work very naturally with that. That's all we're asking. We're not trying to replace anything. We just believe that it's a great option for Kubeflow users.
I'm the first one in favor of replacing ML minus metadata because of the shortcomings, but it would be, for the time being, it would be quite interesting to have a simple switch, more or less an alternative pipeline integration, or maybe really integrate it into the current pipelines repository that you can easily switch and say during pipeline execution, whether you want to use MLflow for all this stuff or whether you want to use Google's ML metadata for the tracking and so on.
Jagan, you mentioned that you looked at the open source MLflow, like you rightly said, doesn't have any authentication or authorization policies, and that's one of the capabilities that you demoed. Have you looked at how Kubeflow does authentication and authorization and exposes those to, or uses those to give users access to Kubeflow's experiment tracking, lineage, and other capabilities?
So I looked at, again, I would be the first to say I'm not the Kubeflow expert, but I did look at all the distributions, how they do authentication and how that relates to the core Kubeflow open source. And I think it is somewhat similar to MLflow in that core Kubeflow doesn't seem to prescribe a specific authentication system, but the distributions have ticked theirs and built around those. I think we can work with that. As for Kubeflow's own artifact tracking and model management, I will admit I don't know enough about it. And I actually think that having options is a good idea. I don't want to be sitting here saying, hey, replace Kubeflow's artifact management for them. That's not where we are coming from. What we think is that there are a lot of users who've got MLflow out there. And if we can make these pieces work really well we have dependencies on some MLflow stuff, like a lot of things we do, we turn it into MLflow runs and we track it back and forth. It makes it natural for us to have a desire to make MLflow work well. But we're not suggesting that it's a replacement for Kubeflow components.
I can tell you something regarding the authentication. Inside Kubeflow, the authentication either works over Istio, and the Kubeflow one is user ID header, which authenticates more or less than the user and therefore more or less the namespace. So you have to think in namespaces inside of Kubeflow. This is the first thing.
Yep, exactly. I think the deployment that we have, or at least the work that we have started around this space, is to have MLflow in the namespace and leverage the Kubeflow's Istio policies, just like how Kubeflow gives access to its experiment tracking. That's how we are exposing MLflow for a Kubeflow customer as well. Just seems like
that is a legitimate deployment of MLflow where it's built into the cluster in question, and authentication and other pieces work naturally. I'd love to work with you to make sure that similar authentication systems can be used for external MLflows. For example, both for Azure MLflow and Databricks' MLflow, you just need to obtain that token, which is a long-lived token, and set that in the environment variable MLflow tracking token, and set the MLflow tracking URI to the external system, and it will just work. So I think it makes sense to look at it as whether it's built-in or external, it will work. I think customers will benefit from that. So yeah, we're happy to work with you on that. I think that's an important aspect of this.
So I know we're over time, but I have a question, if it's okay. This is not designed at this point to be a ubiquitous solution for all models. So there's a pie here of everybody that's using Kubeflow and MLflow, and it's assuming that there are people that are using Kubeflow and MLflow at the same time, and they have no way to kind of work together very easily. It's kind of a cumbersome process. So this simplifies experiment tracking, model management, and data management for the models that are developed using the concurrent workflow.
Yeah.
And it's really designed for a limited set of use cases, primarily unstructured.
Yes.
So I just look at the big pie and I say, this simplifies the slice of part of that pie. And now we need to find out whether users see that as being a valuable MVP. My second question is, does that pie get bigger in a second phase, or is there something else that would allow that? Because I kind of see now we're going to be riding two horses from an operational standpoint, where you're developing some models here, some in KFP, some with the concurrent, some with MLflow. Maybe that's what they're kind of already doing right now.
So
adding a new MLflow, a new ML operation with concurrent, I guess.
yeah, I understand your concern. I think between KFP and concurrent, we can make that integration smooth in that we may have to enhance the KFP DSL to include partitioning information and maybe little more detail on parallelization. I don't know, I'm not making the claim, but if we work that together, then it's basically an instance of KFP that works really well with MLflow. And to the other question of, well, do we need, we're actually very interested in making sure that things like the Jupyter Lab hosting capabilities of Kubeflow work well with MLflow, not just built-in MLflow, but external MLflow also. We want to work, we'll contribute to that also. We are, over and above Kubeflow, the pieces where better integration with MLflow helps, we're happy to, write the code, we're happy to go back to the MLflow community and push them to make specific changes if those are necessary. Maybe better integration of UI where MLflow is built-in into Kubeflow UI. Those are things we are happy to help with. So we do want to do that. The focus was on concurrent because mostly because we see a huge opportunity here where the MLflow community is not interested in building a compute engine, and Kubeflow offers exactly that. It could fit well, and it could be that the sum of MLflow and Kubeflow is bigger than either of those communities.
Yep. And if it's any worthwhile, I mean, that's kind of one data point that we have as well is Kubeflow, like you rightly said, as a compute engine. When it's experiment tracking and runs, you can actually click on a specific Kubeflow component, find all the logs, right? So you get a lot more access to the underlying Kubernetes infrastructure through Kubeflow. The way we have approached MLflow's integration, rightly or wrongly, is if there is a training step within your Kubeflow pipeline, that's where we expose MLflow context through pod defaults. So the training run happens within the MLflow's context and takes the benefit of auto logging feature, right? Like you rightly described. So the ML engineer or the data scientist doesn't have to spit out all the output metrics from a Kubeflow component, because that could be that's a worthwhile exercise, let's say, for the feature engineering steps or other steps within the pipeline. But for the training step of Kubeflow, the way we have set up is that gets the MLflow context, the tracking URI, and therefore everything gets logged into MLflow. And the way MLflow gets deployed in our Kubeflow ecosystem is very similar to the Kubeflow CRUD applications. Like you said, the Jupyter Lab instance of Kubeflow goes through an authorization and authentication policy today. So we kind of use the same paradigm of Istio, DEX, OIDC setup and expose MLflow securely in the same fashion like any of the Kubeflow CRUD apps are exposed. So I think there's probably, like I said, that's one data point. That's how we have done our integration with MLflow.
Yeah, and one of the things that I will comment is that as the industry matures, people really are taking a hard stop, or at least the models are made, the models are published, and then there is a little bit of change of gears. Maybe it's the transfer between the data science teams and the data ops or the ML ops teams. So those who pick up and deploy the model appear to be a different team and different roles in many of the companies that we've spoken to. And in those cases, there are huge amounts of data that is coming in, like the example that I talked about where the honeypot pumps in a lot of data and needs to be processed. So for that case, parallelization is critical. It's very hard for people to build sophisticated applications. We have a customer who's got different models for cardiac cardiac patient status, and they want to look at a CT scan image, run it through a model, determine whether it's a male or female, send it to different other models, and so on. So those sophisticated pipelines are possible with this, and we think that I know I'm rambling a little bit, but But I believe that as the industry matures, there are going to be pauses in between the single sequence of events that you mentioned, Vinay. And in those cases, authorization kicks in, data management kicks in. So I think those are places we need to address.
Makes sense. Yeah, I would definitely be interested in hearing your views around how, like, the data parallelization or the data management part seemed extremely interesting. The way we have tackled it today is just by providing access to the underlying Spark compute from a Kubeflow component. So if there is any partitioning parallelization required as part of your data processing pipeline, we just set up the Spark context and a Kubeflow component executes it. We have an option of running it within Kubernetes, like you said, Spark operator. But today, for example, we just spit it out to the underlying EMR infrastructure. So yeah, that's how we have dealt with it. But yeah, it seemed interesting that your approach is to do it within your within the concurrent product line itself.
Yeah, we went down that path because all the stuff that processes images in NLP is all in Python. It actually is not a good Spark. It's not a good fit for Spark. Like Hugging Face models, they're actually pretty powerful, and people are taking like news articles from the web and running through NLP on Hugging Face models. And the Spark operator is not helpful in that case at all. So there are so many cases, and we think it will grow unstructured, semi-structured, with all Python, and it's Python code that just doesn't fit in a Spark world. So would love to bring out more of those use cases to show. And to Josh's point, is this a piece of the pie that's going to grow? Yes, I think it's a piece of a pie that's the future. It really, I believe that unstructured data is a big part of AI, and I'm impressed with all the work that folks are doing.
I have one question again regarding security. Did you make sure that all of the components that you plan to deploy run rootless? And also you said something which sounded dangerous, building OCI containers inside the platform. This usually requires root writes.
Okay, you're killing us. Sorry, no. There are two things. You identified the OCI legitimate point. We need to be able to create containers. Otherwise, people have a hard time using the system. The second point is we have a fuse mount system we use. A lot of Python software out there doesn't know about object stores, just wants to deal with local files. That's all they know. So Jitendra has built the system where object files from object stores, when they're partitioned and they are dumped into the particular container, they show up as a fuse mount and just local directory. So our API gives you the ability to just identify those local files and use those. So we need root permission for that also. I really want to talk to you about that, because we think that having people create containers and pushing it to the container registry is a showstopper. We're not going to get users at all. 100% of the data scientists will walk away from that when we say, hey, make a container, put it in the data in a container registry, and then run your job on KFC.
But that is the case currently for Kubeflow. It runs, if you want to use istio-CNI, it runs completely rootless. All of the pipelines run completely rootless. You just pre-build the containers that you want to use. And then, of course, you can add PVCs and so on. But I think this is one very critical thing, that you make sure that whatever you integrate into Kubeflow, it does not need root writes.
Okay.
I think it's one of the very important things, because otherwise you can completely break enterprise security.
Okay. I mean, are there any exceptions to that? In other words, can users reconfigure or configure their Kubeflow instance to say, for this, and this application, allow root access? Is that even, has that come up, or it is a hard and fast rule that root will not be allowed?
No, from a legacy standpoint, sadly, Kubeflow has some root stuff. I spent the last 1 or 2 years to remove all of that and make it possible that Kubeflow runs without root writes entirely. And of course, we cannot give any user partial root writes. As soon as they have root writes, they have them. But I think there should be ways around it, because all components of fine Kubeflow easily manage to do so, to not use them. For example, the Kubeflow pipelines executed using Argo, either they use PVCs or MTDs to store data, or they use they have a set of pre-built images where they build on top of, and I think there should be a possibility to achieve the same within MLflow, because most corporate enterprise environments that I know of, they will just throw you out the door if you come to them with the idea, just the idea of root containers.
Okay. Okay. Yep, that's very legitimate concern, and so we can take this discussion offline. I do want to follow up with you on what your experience is and see how we can, work our system into the way. Maybe turn the container creation aspect into a service in Kubeflow, and I'm assuming services have the ability to do. To be root. Let's take this offline and discuss. This is clearly interesting. Jitendra, go ahead. Yes.
Yeah, because one of the concerns is that when we launch a root container, user code should not be running there. I think that's the key problem in all these systems, that if user code has access to more privileges than they need to, then there could be a problem. So our bootstrap part is okay, because in bootstrap, we do not use user code. What we have to look at is the fuse mount, because so we can narrow it down and figure out.
We'll get in touch with you. I think this is a very, very good point that you bring, and I'm glad you brought it up now.
Yeah, you can always reach me on the Kubeflow Slack or on GitHub.
Yeah, sounds good. Any other questions that deserve follow-up? Josh, I'll look to you for next steps.
Yeah, I mean, I really think that we need, and I'd like to see users kind of weigh in on this issue. I don't know how long we need this to soak, but considering the magnitude of what needs to be delivered, tested and documented, and if we are looking to have some kind of first phase of something like this in Kubeflow v1.7, which would be in March, there's not a whole lot of time. We need to get some folks to provide some input. One thing that I think would be interesting is if we could find users to weigh in, and especially a lot of the larger users that might be using both MLflow and Kubeflow, if they have some form of sandbox, and they could actually potentially walk through this and see if they see value. My concern right now, a little bit on this, is beyond the technical complexity, is the operating functionality for the end user. And if they have to figure out, I've got to do one model over in MLflow, one in concurrent, and a different one in Kubeflow, how do they pick and that type of thing. I want to see if there's some way to simplify and make sure that the ones that go to concurrent fit well and will be successpull, right? Yeah. Rather than trying to force fit something in that would not fit in there.
Yeah, makes sense. I understand. We'll push forward. I think we need to give at least a week for input feedback on this, and we'll reach out to some potential users or users. We do have a sandbox that people can play with, can sign up and just play with it. That's very easy to do, and we'll try to document more of this. We will do some more work on where, how, and what pieces we're going to integrate into Kubeflow, what will become part of core Kubeflow, and where the integration will be. So let's plan on having some more material on that in the next week or so.
It might be good, and I'm not trying to put extra work, but maybe you guys want to have another follow-up call, invite users and other folks, again, just try in a 30-minute update of where you're at, just to keep the momentum going, so you can keep getting comments and see if this thing will grow as we move into the Kubeflow Summit. As I suggested, probably this is one of those topics that's best to discuss in person if possible. But
that would be wonderful. Yeah, I mean, we want to be in that. I will follow up.
Okay. All right, well, let's see how this kind of progresses, but great job. I learned a lot. I hope other folks on the phone did learn from this. And this was recorded. I think it'll be also interesting to see how many people watch the video recording too. If you get 20 or 30 people that jump in and watch over the next week, I think that'll be a real you know, sign that there's interest in the space, right?
Absolutely, sounds good. We will put up the recording forthwith and post on the Slack and the Gmail channel. I think it's a path of least resistance. Trying to get it into Kubeflow's YouTube account may be a longer challenge. So let's just put it up, post there, and invite people to view it and ask questions. We'll see where we go.
Super.
Thanks, folks. Thank you all for attending. Really
Everyone.
appreciate the time you've taken.
Thanks, Judgine.
Thank you.
Thank you. Thanks.